Engine Performance 2, Test 4. That was the one that I put up there, but that was by itself, you remember? Because I forgot to print it. And so we're going to start out by asking, what is global generic OBD2? A, same for all numbers and models of vehicles. B, format originally designed for engineers. C, standardized format that meets Society of American Engineers Standard J1962. Or D, all of the above.
D.
What?
D.
D, all of the above. So basically, we have the same connector under the dash that we can plug into and get OBD2 data from any vehicle sold in the United States. The PIDs, like your ECT and IAT and that, is sort of is on a J standard. All of these SAE standards are like, you've got your different regulations, like the J2788 is a new standard for air conditioning and refrigeration. Air conditioning recovery and recycle equipment. Mine is not J2788 compliant, but I can use it until I decide to get a new one, and it's okay. Mode 6 can be used to verify a repair by checking what?
B. Sensor values.
Non-continuously monitored systems. Basically, you got to drive it a little while before that pops up there.
You just read number 2 and then gave the answer for number 3.
Sorry about that. I sure did. I just messed up. Number 2 is going to be, well, the component system test passed is basically what it was. And so mode 6, it also checks non-continuously monitored systems. So, both of those answers are the same deal. Except, you verify the repair by seeing that the component test passed. Now, the hardest component test to pass, every trip that you make when you're doing emission stuff is going to have a particular criteria that has to be met if it's non-continuously monitored. You can always monitor your throttle position sensor and your engine coolant sensor and the stuff that's basically going to be operating all the time. What's something you can't monitor all the time? We've talked about this before.
Oxygen sensor. Oxygen
sensor is something that's got to be, a certain criteria has got to be met because it's not always working. When it's cold, it takes a little while to come on. What about the thermostat? It won't know until a certain amount of time when the engine running has passed whether the engine's getting warm enough or not. Catalytic converters got to reach a certain temperature and stay there for a certain amount of time before it's going to know if that's good or not. The hexadecimal number for 12 is what?
B.
Huh?
B.
B. Why? Why would you say that?
Just take a guess.
Huh?
No, just guessing.
You're just guessing? I thought you were smart because B is the right answer. $C is the hexadecimal number for 12. And so what we all need to do is we need to learn how to count in hexadecimal numbers, right? Can you do that? Will that be good? Technician A says, by looking at the mode 6 data, the technician can determine how close a component or system came to passing the onboard test. Technician B says the data shown may have to be converted to obtain values that are meaningful to the technician. Who's correct about that? That's technician B, actually. Basically, I kind of like A's answer too, though. I mean, I really kind of like his answer, but you got to tweak that a little bit. Like you say, basically what you're looking at is your minimum and your maximum, and if the value that was tested falls outside of that, that's when it fails, for the most part. The data display usually shows what information? I'm talking about, this is mode 6 is what we're talking about here. What you got? You got upper lower limit, upper limit and lower limit, upper limit or lower limit, test results. It's actually both B and C. Oxygen sensor switch time from rich to lean is identified as test identification what? See how those numbers are? This is what you usually see on most scan tools, is these hexadecimal things, and it's a $05. That's basically the hexadecimal code for oxygen sensors. And don't expect me to have those memorized either, so if you ask me, I'll have to say I'm not sure what that one is. We'll have to find out. Type A misfire codes are those that can damage the catalytic converter and usually have misfires that range from what at idle to what at high engine speeds? Anybody know? 40% to 4%. You know what they did when they were first talking about this on your misfires? They would actually monitor a bracket of engine operation that was like 200 revolutions of the engine and 1,000 revolutions of the engine. Okay, have you ever heard, like we were talking about before, a misfire? Whenever somebody's car stops next to you or whatever, you may hear the exhaust there. You may hear it going boom, 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 boom. You ever heard that? I mean, the exhaust coming out of the exhaust, instead of a smooth boom, it's got a boom, 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 boom. That typically means that you got spark plug fouled. Usually got cracked ceramic down there. It's firing most of the time, but there's sometimes when it's not firing. If a spark plug is gapped too close, it will act like that. And I have actually had people bring me vehicles and they say, I put plugs in my car now, it's not running smoothly. I hear that, I pull the plugs out and I find some gaps that are way yonder too close and all that. So that's. But if you're looking at 200 RPM or 200 revolutions of the engine, and you've got misfires that are taking place repeatedly within 200 RPM windows, that's a type A misfire. That's a misfire that could be damaging to the catalyst. Why? If it's misfiring because of an ignition problem, you're still squirting fuel in there, and that unburned fuel is going down to the catalyst, which is already probably running about 1200 to 2000 degrees, and you don't want a meltdown going on. You know what they're replacing the metals in the catalyst with now? They're talking about doing that, and there's been some work on it. Fake rubies.
Are you saying fake?
Fake rubies. Yeah.
You don't want them made out of.
Yeah, they're coating the catalyst strata with fake rubies.
What are they made out of if they're not real rubies?
Yeah. Well, because real rubies would be too expensive. You know. But what I mean is they're actually like man-made rubies. You know what I'm saying? Like you can make diamonds. Okay. So they're man-made, and they basically from this little article I read the other day, and it was in a Cutting Edge magazine. They were talking about that. As a matter of fact, if you're on my Technical Writer Facebook page, there's a text I posted from an article about that. You can find it on there.
I guess palladium and platinum are just getting too expensive.
Yeah, it definitely is, and if they can do it with something else, why not do it with something else? And that's privileged information. So I don't know.
I guess it'll stop people from in the future cutting off catalytic converters.
Probably so, because that would be a great idea, because if there's no platinum and palladium in there, if it's got fake rubies, as a matter of fact, you could probably get a temperature-proof label and put on your catalyst saying, this catalytic converter contains no platinum and palladium, it's made with fake rubies. Whenever I was working at the car dealership over there, and we would go, and ever so often, they wouldn't let you do it every day, but you could go in there and get a can of gasket glue that had the brush in the can and all this kind of stuff, and it would be signed out on a purchase order for shop supplies. Well, when you put it on your bench, these other yo-yos wouldn't look after theirs or whatever, or they lose it, or they just would need some, and they had maybe took it home. I don't know. They come by and get your dadgum gasket glue. You know how people are that when you're working with them, annoying as all get out. And so I got an old round oil can. We used to use round oil cans, and I cut the bottom out of it. It's just a crummy looking old oil can, and I made a little thing to camouflage my gasket glue because it just fit perfectly. And that oil can's sitting there, nobody'd ever touch it.
I would have just filled it up with something that wasn't gasket glue.
Yeah.
And then grab it.
Yeah. Yeah, or something like that. Well, I actually got some, what I got also with carburetor spray. If people came by and saw that you had a can of carburetor cleaner, they're going to grab it and run off with it. Then when you go in the parts room and get some more, they say, why are you getting so much carburetor cleaner? Well, somebody keeps stealing mine. So I made fake labels for them that said, liquid manure. And nobody would touch it. They just leave it sitting there. You got to play the head game, you know what I mean? Okay, let's see. That kept me from, getting ill with people. General Motors vehicles being checked using Mode 6 data for the proper operation of an oxygen sensor. The rich to lean sensor switch time is around 0.030 seconds. What is that? That's 30 milliseconds, isn't it? If it was 0.300, it would be 300 milliseconds, wouldn't it? Which is not very much. Technician A says this indicates slow reacting oxygen sensor. Does 30 milliseconds sounded like it's slow to you?
Yep.
What? Do you do
Generally.
anything? Do you do anything that fast? You don't even blink your eyes that fast, do you? Do you sneeze that fast? All right then. Technician A says this indicates a slow reacting oxygen sensor. Technician B says the oxygen sensor is reacting correctly and is okay. That's B. You want to see the oxygen sensor whipping up and down like this. Now, sometimes you got a code nowadays that will say the oxygen sensor is sluggish and slow. Occasionally, in the olden days, I used to see oxygen sensors that would go to sleep for a little while and then wake back up and start working normally. And when it came in, you would actually see a code for that the oxygen sensor had read lean for a while, and then it would start, correcting to the rich side and cause issues. And I would, you just pop an oxygen sensor on that one and usually fixed it. If it's doing fine now, but it's got a code that it was running lean earlier, and there's nothing wrong at this point, the fuel trims look good, you throw an oxygen sensor at it. Mode 6 information can be accessed where? Now this is a good question right here, really, isn't it? http www.nastif.org. You know what that is? The National Automotive Service Information Task Force, I think is what that stands for. I've actually had an article published on that website. Another one is motorcraftservice.com, and another one is servicegm.com. So if you want to know about your Mode 6 information, what these little hexadecimals stand for, you can go to one of those websites and pull it up. Is that useful information? You got a scan tool that's telling you that, and you don't know which one failed, go find out, pull that up. The hexadecimal number for 6 is what?
B.
That's a D. Yeah, it'd
Also,
be,
I think I forgot
it's
how-
actually, yeah, it's 11, it's actually D.
Well, I'm guessing it goes up to 9, and then it goes A, B, C, and all
Yeah,
the way to F.
yeah. I like the way you think, Adam. All right. Mode 8 is the mode that checks with which of these systems? Bi-directional control of onboard systems. Is that right? That's right, isn't it? What's bi-directional control?
You can talk to it and it can talk to you.
Yeah, basically, we were doing yesterday on that car was we hooked the scan tool up and we were attempting to get the scan tool to tell the fans to come on, right?
Yeah.
For some reason or another, we had some sort of a disconnect, or we weren't doing it right or something on that particular car, or it wasn't working right itself. But it turned on all the relays, but it wouldn't turn on the fans. But we found out that what the problem was, didn't we? All right, let me see here. Where am I at here?
Number 15?
13.
13. I meant to say mode 8. I didn't mean to say. Yeah, I said that, didn't I? Did I say mode 8 or did I read something else? Yeah, mode 8. An oxygen sensor maximum sensor voltage test for test cycle is identified as test identification what? That is D, $08. It'd be great to memorize all these, wouldn't it? An oxygen sensor switch time from lean to rich is identified as test identification 6. That's C, $06. Which of these global OBD2 modes is used to clear and reset diagnostic trouble codes, freeze frame data, and readiness status monitors for non-continuous monitors only? That's going to be D, mode 4. See, you got a bunch of modes on this thing, 9 modes. Technician B misfire codes, type B. I get used to saying technician A and B, so when I see a T word with B next to it, type B misfire codes are set if the misfire exceeds what to what, depending on the engine make, model, and year. That's Charlie, 2 to 4%. How does the thing know that it's misfiring and which cylinder is misfiring on? Think about it, reverse engineer it in your mind. You're the engineer, you got to come up with a way for it to do that. How's it going to tell if it's misfiring? What do you have? What information are you getting from the sensors on the engine that can help you determine if an engine is misfiring?
Still like soon.
You're looking at the crank sensor. It's got the missing tooth, 36 minus 1. So every 10 degrees of crankshaft rotation is recorded, right? You got that. Okay, you've also got the chem sensor, which is telling you what? Which sensor is on top dead center compression. Which cylinder is on top dead center compression. Okay, Now then, you've basically got a picture that you've stored of what it looks like whenever the engine is operating smoothly. So if I've got to get a smoothly operating engine, if I've got to learn, if I'm the computer and I've got to learn what it looks like when it's not misfiring, I got to learn that. How am I going to learn that? What mode of driving would be the best mode to learn that? When is the engine not going to misfire and change speeds? It changes speed a little bit when it misfires, doesn't it? It slows down during the misfire because that cylinder is not carrying its share of the load. Okay, so what mode of operation during normal driving can give me a picture of what it's going to look like? Because the computer's like us. The computer's got to look at what's good so it'll be able to recognize what's bad, right? Chrysler calls this particular piece of information that it gathers an adaptive numerator, okay? That's a strange, but General Motors calls it crankshaft learn. There's a bunch of different names for it. But the point is, if I'm driving and I let off and I'm just coasting, after I've coasted a certain amount of time and it has taken enough snapshots of me coasting, now it knows what it is when the entire engine is turning at even speed and it's not slowing down on any one cylinder. Now, everybody knows, and I always like to see if you can remember this, what happens to the fuel injectors when you let off the gas and you're going down a hill? They turn off. You know that? Did you know it turns off the fuel injectors when you're coasting down a hill? And the logarithm is typed this way, or the little program code. It says, at a calculated pulse width of less than 1.2 milliseconds and an engine speed greater than 1200 RPM, the injectors are turned off until the calculated pulse width goes above 1.2 milliseconds, and then they're turned back on again. Okay, so my friend asked me the other day, he said, would I save gas putting my car in neutral and coasting down hills? And he's driving a Toyota Camry. And I say, no, you'll probably burn more. And he said, how come? Because he's seeing an RPM that's higher when he's coasting down the hill because he's got some engine braking going on, And I said, because it's going to run your injectors at an idle when you're put it in neutral, but if you let it coast, it's going to shut them off. So you're actually going to save gas by just leaving it alone and just coasting down the hill. I say that kind of stuff because if I don't, I'll forget it, and you guys kind of need to know that because of what we're talking about. All right. Let me see. Number 17, Technician A says by looking at the Mode 6 data, the technician can check the monitor status before starting repairs. Technician B says you can look at the component or parameter that triggered the fault. C is right on that. Mode 6 data is pretty cool stuff. You learn how to use it. An estimated blank of the PCM diagnostic trouble codes can be diagnosed using the global OBD2 function of the scan tool.
C.
That's actually D, 80%, but not 100%. There's some of them that can't. And remember, I told you there's 2 rooms in every engine controller, and you need to look in both of those rooms. Look in the OBD2 room, look in the enhanced room, because you're going to have different codes stored in each one of those. Sometimes if you're just using OBD2 and it pulls up a P1 whatever code that's a manufacturer specific, your generic scan tool will just say manufacturer specific code. It won't tell you what it means. Some of them will, some of them won't, but one way or another, Technician A says non-continuous monitors include catalyst efficiency, EGR, evap, oxygen sensor monitors, oxygen sensor heater, secondary air injection, and thermostats. Technician B says mode $04 is used by service technicians to monitor the PCM test results of various systems. That's Technician A. And finally, number 20 says Technician A says some scan tools translate the raw hexadecimal data into English using software and a PC. That's what we just saw when I showed you guys that out there. Technician B says this system makes the data easy to read. Which technician is correct? That's A. And I don't know why all of the scan tools don't do that. Instead of just throwing you those hexadecimal numbers. I've always not been happy with that.
What's 16?
What's 16? Charlie? All right. Anybody got any questions or comments?
Oh, one more you said.
Huh?
Said